Thank you. Hello, everyone. My name is Gamanjie, and currently I am a senior field engineer at Apple. I have joined Apple 3 years ago, and as part of this role, I am bringing Kubernetes and cloud-native expertise to different teams and products within Apple. In addition to that, I am one of the TOC, or Technical Oversight Committee member for CNCF, or Cloud Native Computing Foundation. As part of this role, I am joining 10 other champions within the industry, and we aim to provide a technical vision for the wider landscape. I have many other roles in the community, one of them being the creator of the Cloud Native Fundamentals course, which you'll be able to find on Udacity, and I'm one of the lead for the KCNA certification as well. In addition to that, I'm an industry-level awarded professional, and I have been nominated and elected as the Next Generation Leader by Women in IT Awards, and won the Tech Woman 100 within the UK. Today, however, I would like to talk about Sustainability Chronicles, and more specifically how we can innovate for green technologies by using tooling such as Kepler and KEDA. And to begin with, I would like to introduce the notion of cloud sustainability. Here, I would like to emphasize why it is important for the tech sector to take action when it comes to their emission and be responsible in this regard as well. Next, I would like to apply sustainability to the cloud-native context. So pretty much, how can we measure our emissions within the Kubernetes clusters? For that, I'm going to introduce two tools, one of them being Kepler, which will allow us to create this inventory of our emissions. And the second one is going to be the KEDA Carbon Aware Operator, which will allow us to scale our applications up and down based on carbon intensity. And finally, I would like to focus on community sustainability. While the technology is the gravitational point for our ecosystem, none of it would be possible without a community around it. And here I would like to emphasize the need for us to create this nurturing space for the next generation of cloud-native practitioners to operate in. Now, before I move forward, how many of you here know about Kubernetes? Can I have a show? Awesome, amazing, love this. So as you know, Kubernetes is turning 10 years this year. This is a wonderful milestone for our community. And if you look in perspective, we've actually done a lot of work to change how entire sectors and industries are approaching their infrastructure build-out and management. Over the time, we had multiple tools built around Kubernetes to extend its functionalities, such as support for different networking, storage, service mesh, and many other functionalities. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. This is the landscape that we, the TOC, are working with and provide that technical vision for. We'll work individually with every single project and will ensure they reach the maximum amount in their maturity level. Now, currently within the landscape, we have more than 180 projects which are fully open sourced. And all of these projects are dispersed across 3 different levels of maturity. We're going to have sandbox, incubation, and graduated projects. Sandbox are all of these projects that provide a solution for a niche problem space. These are greenfield ideas. Next, we're going to have incubated projects, and here we already see some adoption from different organizations and contributions as well. And finally, we have the graduated projects, and these are the projects we refer to as the ones who crossed the chasm, so pretty much moved from the early majority to early adopters. These projects are here to stay, and they usually provide an industry standard within that problem space as well. Now, within CNCF, we have 113 projects which are in sandbox, 37 are incubated, and 26 are graduated. As well, I would like to draw your attention towards the grain-faint line at the top of the graph. These represent our archive projects, and I don't think we talk sufficiently about archival. Sometimes it is only natural for some of the projects not to reach that number and momentum when it comes to adoptership and contributorship as well. I think it is very important as a community to take this lesson learned and move our efforts either to existing projects within the ecosystem or create a new initiative and open source it. And currently within the TOC work, we have focused a lot on archivals as well. So at the top of the graph, you'll see that we have more archivals happening in the last 6 months. And currently, we have 7 projects with this status. Now, considering the ongoing success for Kubernetes and the growing cloud-native landscape, you might ask yourself why sustainability matters and why it matters now. The short answer to this question is that currently we have multiple incentives to intertwine the economic growth and climate responsibility. And this is because of 2 factors. The first one is COP21, which took place in Paris in 2015. This led to a climate agreement to keep the global warming between 1.5 and 2 degrees Celsius. The second factor is the United Nations SDGs, or Sustainable Development Goals. SDG 13 is focused on climate action, and it emphasizes that as humanity, or this globe, we need to approach sustainability in a more proactive manner. Now, both of these factors resulted with regulations at the national level, which in turn resulted with different organizations reporting and assessing their greenhouse gas emissions. And we can see this in numbers as well. Now, currently, the tech sector is responsible for 1.4% of global GHGs, or greenhouse gas emissions. If we'd use renewable energy to power our infrastructure and data center, these emissions would drop by 80%. However, if we don't take any action, these emissions would raise to 10% of the global GHG within the next decade. As you can see, we are at a crucial standpoint, and as a tech sector, we really need to address sustainability at every single org level. We need to drive these remediation strategies, build expertise in-house, and ensure we think about our emissions at every single development step as well. And as part of this mission, we already have the big cloud providers setting the net zero targets for themselves. And they're going to look into two main areas at the moment, using renewable energy and offsetting their carbon footprint. Now, when it comes to using renewable energy, we already have most of the organization aiming to do so by 2030. Actually, 2025, which is going to be next year, with GCP already running their infrastructure on fully renewable energy since 2022. For carbon-free offsetting, most of the organizations set a target for 2040. GCP aims to do so by 2030. In addition to that, we have Microsoft, which aims to reduce deforestation, be water positive, and achieve zero waste certification. However, we should not delegate sustainability and addressing of emissions to cloud providers. We need to include this within our organizations as well. And this led to the creation of a new school of thought, which is known as GreenOps, which derived from the FinOps Foundation. Now, GreenOps encapsulates all of the processes, tooling, cultural, and behavioral changes related to climate and digital sustainability. Now, the question is, why derived from the FinOps Foundation? This is because we can see a clear benefit between efficient management of your infrastructure and a positive sustainability impact. For example, if you have been looking into FinOps principle, one of the things that you will aim to do is to address the cost for your infrastructure and products and reduce that cost as well. So for example, you might be looking into using spot instances, or you might move from a SaaS solution to serverless, so only having an instance of your application running only when needed. Perhaps as part of the same effort, you might be looking into using a different programming language to have your application more optimized for your infrastructure. Now, all of this will result in less compute used and less cost. But because you have less compute, that means you have less emissions, and by default, you're going to have a positive sustainability impact as well. In addition to that, the Environmental Sustainability Working Group from the FinOps Foundation came up with a strategy on how to include sustainability within your organization. And this is composed of 4 main phases. The first one is awareness. Here's where you'd like to talk about sustainability to all of the stakeholders internally. You want to introduce these notions of carbon footprint, greenhouse gas emissions, all of this new terminology you'd like to assess, introduce, and kind of fill the engagement within your organization. Next, we have the value discovery stage, and here's where all of the POCs are happening. Ideally, here we'd like to benchmark or have this inventory of your emissions. If you use a cloud provider, you'll be able to use some of the existing calculators. They have the names such as carbon footprint or sustainability calculators. The idea is you have to start somewhere, and that's going to be your baseline. Again, in this kind of phase, you can look into tooling such as Kepler and KEDA, which I'm going to talk about next. The next stage is going to be roadmap. Here's where I'd like to introduce all of these tooling and processes within your organization. Automation, this is what we're looking for. In addition to that, we want to address any anomalies. And this is going to ensure that we have qualitative assessment of our emissions. And finally, we're going to have execution and repetition. And here's where it's very important for us to have these very ambitious goals for our sustainability and emission, and in a repetitive manner, aiming to achieve those. Now, so far, we can see that addressing emissions, as any tech organization, it is crucial for us. We need to build this muscle of carbon accounting and ensure we have an inventory of our emissions per organization, team, and product. The question now is, how can we do so within a Kubernetes cluster? How can we address this in a cloud-native context? Well, for that, I'm going to introduce two tools, which are Kepler and KEDA Carbon Aware Operator. Let's actually start with Kepler. And before I mention anything about it, does any of you know what Kepler is? Maybe heard about it before? Oh, some hands. Perfect. Now, for anyone new to Kepler, this is a Kubernetes efficient power level exporter that uses eBPF to probe the system stats and export this to Prometheus as metrics. Now, Kepler was created by Red Hat and IBM in 2022, and it moved to Sandbox within CNCF in 2023, May last year. And here, I'm going to put my TOC hat on as well. As you can see, Kepler is a sandbox project, which means that it provides a solution for a greenfield idea. There's definitely growing momentum within this space, but I would definitely like to encourage you to explore Kepler, and if you have any adoption feedback or any contribution suggestions, I definitely encourage you to do so. Now, looking into the Kepler architecture, currently Kepler is going to be deployed as a daemon set, which means we're going to have a replica of the Kepler exporter on every single node. And this will allow us to collect two levels of metrics, node level metrics and container level metrics. And mainly we're going to look into the power consumption and resource utilization. We're going to do so by using eBPF to trace the CPU performance counters and Linux kernel trace points. We're going to export all of this to Prometheus for data aggregation, and we'll be able to visualize it with a tool such as Grafana. Now let's look into how Kepler actually calculates our emissions. The first thing we're going to need is an input value, which is going to be the amount of energy consumed by our application. Now, Kepler is going to actually calculate the amount of joules that are consumed by our application, which is going to be converted in kilowatt hour. This is going to be our input value. Next, we're going to multiply that by an emission factor. And currently, Kepler reports the emissions for three main gases: coal, petroleum, and natural gas. Now, these emission factors are hard-coded value, and they're going to be dependent on the country and the region you're actually running or powering your infrastructure from. In this particular case, I've taken these coefficients from the US Energy Information Administration. Now, the emission factors represent the pounds of CO2 or carbon dioxide emitted per kilowatt hour consumed, which means that our output value is going to be the total amount of CO2 emitted per emission gas. And how it's actually going to look like? I have deployed Kepler within Kind and have running an application over there as well. I have used the Kepler Grafana dashboard to visualize my emissions as well. The first thing I'm going to be faced with are three gauges that showcases the emissions per gas. So here we have the coal, petroleum, which in this case we're not doing very well. But for natural gas emissions, it's actually on the green side, so we're doing well. At the top, you'll be able to see these emission factor coefficients, which are hard-coded. Now, if you're running in a cloud provider such as GCP or AWS, you'll be able to get these emission factors from this provider by default, and you'll have more granular data when it comes to your emissions. In addition to that, with Kepler, you'll be able to see your emissions per container, day, and namespace. So for example, if you have a very spiky day within your organization and you have a lot of traffic coming to your applications, you'll be able to identify those components or applications that have more emissions and be able to address them. If you have a namespace as a service solution, you'll be able to identify the namespace/team that produces those most emissions. Now here again, it is very important for us to have this baseline of our inventory, which Kepler provides, and monitor it as well. Now, after having the baseline, this is great for us to just observe our emissions. We need to address them. The next question is, how can we be more proactive when scheduling our applications and having sustainability in mind? Well, for that, we're going to have the KEDA Carbon Aware Operator entering the picture. But before I do so, I would like to talk about KEDA. And again, a very quick show of hands, since many of you know Kubernetes. How many of you know KEDA? Perhaps heard about it. How many of you are using it in production, though? Oh, not so many. Cool. Now again, for anyone new to KEDA, this is an event-driven autoscaler that pretty much scales your application based on an external event. KEDA was created by Microsoft and Red Hat in 2019. It was donated to CNCF as a sandbox project in 2020, moved to incubation 1 year later, and then to graduation last year. Again, I'm going to put my TOC hat on here. KEDA is a great example to showcase how a project traverses different maturity levels all the way to graduation. I definitely encourage you to explore the charter, the governance, and all of the work around this project as well. They have a great example on engaging the community and creating that roadmap. As well, I definitely encourage you to look for the due diligence processes, which is all of the interaction the project had with the TOC in order to reach the graduation level. Looking very quickly into KEDA architecture, currently to scale any application with KEDA, you will need a scaled object CRD, or customer source definition. And this CRD will have two levels of configuration. The first one is going to be the application you'd like to scale. It can be a deployment, stateful set, or another CRD. The second level of configuration is going to be the event or trigger you'd like to monitor and assess in order to scale your application. With KEDA, we'll be able to scale our application all the way to 0 and 1, but more importantly, works in conjunction with HPA, or horizontal pod autoscaler, which means we'll be able to scale our application to desired amount of replicas. In addition to that, KEDA has a very rich catalog of external triggers, which you'll be able to integrate and use within your cluster straight away. Now let's go back to sustainability. How can we scale our application having carbon emissions in mind? For that, we have the carbon-aware operator entering the picture that aims to optimize the carbon emissions and environmental impact by scaling your applications based on carbon intensity. Now, carbon intensity is the grams of CO2 or carbon dioxide equivalent emitted per kilowatt hour consumed. What it actually means. If you're plugging, for example, your data center or infrastructure directly into a solar or wind farm, your carbon intensity is going to be 0 or close to 0. This is because you do not emit any carbon dioxide while consuming that energy. In a more realistic example, however, you're going to have energy from different sources. Some of it can be from burning the coal or fuel, some of it can be renewable energy. Hence, you're going to have a varied level of carbon intensity. To scale any application by having this carbon intensity in mind, we need a carbon-aware KEDA scaler, CRD or customer source definition. This particular object is going to have 3 levels of configuration. The first one is going to be a reference towards our scaled object. So pretty much what application we'd like to scale. In this particular case, it's going to be an application with the name demo scaler. Next, we're going to need our forecast for carbon intensity. And there are 2 ways to get that. You can either plug in directly into a grid and get that coefficient for your intensity directly from the provider. And some of these providers are watt time and electricity map. For this particular example, however, I'm using mock data, which means that my carbon forecast, mock carbon forecast variable is going to be set to true. And finally, towards the end, we're going to have the behavior of our application scalability. The main idea here is that if our carbon intensity is high, we want to have the minimum amount of replicas because we have more emissions, and vice versa. If our carbon intensity is low, we want the maximum amount of replicas. In this particular example, I'm having 15 amount of replicas when my carbon intensity is 443 or less, and I'm having only 1 amount of replica if my carbon intensity is higher than 579. And how is it actually going to look like? After I deploy this particular CRD within my kind cluster, and I'm using a Grafana dashboard to visualize my carbon intensity, I'm going to have this graph. In this particular example, the top line, the green line at the top, represents my carbon intensity. The yellow line represents the amount of replicas that I have. So in this particular case, we're starting very well with a carbon intensity of 530 and 15 amount of replicas. Now, towards the middle of the graph, you'll be able to see that our carbon intensity is going higher to 580, and our amount of replica is going all the way to 1. And this behavior is going to be replicated through and through based on the carbon intensity we get directly from the grid. Now, so far, we talked about how can we address emissions within our Kubernetes clusters. We talked about Kepler, which will allow us to create this inventory of our emissions, but at the same time, we talked about how can we dynamically scale our application based on the emissions we get from the grid. Now, whilst the technology is the gravitational point for our community, none of it would be possible without the community around it. Now, from the beginning, the Kubernetes community operates on the principle that inclusive is better than exclusive. We create, build, and retain contributor community through a open governance, transparency, and a diligent code of conduct. This is what pushes innovation forward and invites everyone to contribute. Now, if you'd like to be an active member of our community, I definitely encourage you to go to contribute.cncf.io, where you'll be able to find more details. Here we have different guidelines and a list of all the projects that you'll be able to get involved with straight away. However, contributions are not only measured in code. You can get involved in many different ways. For example, you can provide feedback in regards to how you use an application, or you can participate in different guidelines in regards to how security is approached within an industry. All of this work is done by our tags or technical advisory groups. These are our micro communities that are created by SMEs in the area, and they focus on very niche domains, such as observability, security, networking, and of course, environmental sustainability as well. Now, Tag Environmental Sustainability was created just over a year ago, and it aims to put sustainability on the agenda of all graduated projects. Currently, they have the so-called green reviews, which aims to benchmark the emissions for all of these cloud-native projects and make them more aware of their emissions as well. Now, if you'd like to get involved in any of the tags, you can do so straight away. All of the information about them is publicly available on GitHub. You'll be able to find the charter, governance, all of the current leaders, working group leaders, and ongoing efforts as well. All of the meeting notes from previous meetings or future meetings are also available. So you'll be able to join these communities starting next week. Now, as a community, we need to always create this nurturing space for the next generation of cloud-native practitioners to operate in. And we need to do so through a culture of education and upskilling. We need to scale at the same pace with the technology growth. Now, when we talk about education, we have multiple resources in this regard. Some of them are the free professional level certifications, which are CKD, CKA, and CKS, or pretty much certified Kubernetes application developer, administrator, and security specialist. Now, we had some feedback in regards to these certifications. And more specifically, they are too high level of an entry bar for new community members. We have heard this feedback, and as part of this effort, we introduced KCNA, or Kubernetes and Cloud Native Associate Certification. Now, this is a multiple choice entry-level exam that allows anyone with interest in cloud native to demonstrate their passion and interest within this space. And following the same example, we have multiple new associate level certifications focusing on observability, networking, security, GitOps, and many more coming. As part of the same mission, I have created the Cloud Native Fundamentals course, which bridges the gap between DevOps and the usage of Docker containers all the way up to using an orchestrator such as Kubernetes. As a community, we always need to remember that we are working on software that changes entire sectors and industries out there. We need to create this new environment where feedback and ideas are welcome, but at the same time, we need to further diversify our technical and governing boards and advisory committees. We should always strive to build and diversify our community. And this brings me to the perspective today. So far, we talked about the notion of cloud sustainability and why it is important for the tech sector to actually take action and be responsible about their emissions. Next, we talked about how we can apply sustainability to Kubernetes for tooling such as Kepler and KEDA. And finally, we talked about why it is important for us to scale at the same pace with the evolution of technology to ensure we have a healthy community. And all of this has been possible because Cloud Native currently is a center of innovation that enables us to use and innovate through green technology by being aware of our carbon emissions and environmental impact, but at the same time, it encourages us to do so while building a healthy community. And without saying, we are hiring. If you'd like to work for Apple anywhere in the world, I definitely encourage you to go to jobs@apple.com, where you'll be able to find the latest openings. If you have any questions in regards to the interview process or how it is to work at Apple, please reach out. I'm more than happy to answer. If you have any questions in regards to today's talk, you'll be able to ask them thereafter, or you can find me on social media such as Twitter and LinkedIn. This is Gamanjie, and I look forward to seeing how you can shape the cloud-native ecosystem. Thank you, and enjoy the rest of the conference.
We thank you, Katie. We do have time for a question, so we have a gentleman over here with his hand up, so please go ahead.
So, oh, thank you.
It's a lot
So
better, yeah.
the massive compute power for AI may even dwarf the Kubernetes abilities and efforts. So what do you think about that?
That's a good question. I think these efforts are going in conjunction because they are under different tags. So quite recently, we have released our AI white paper, and it was created in conjunction with tag observability and network. So we have already community members focusing on that effort. When it comes to sustainability, we have a different micro community of that. I wouldn't say they're competing, they're just developing in different directions and vectors, and very much possible with our growing community too.
So you are working on mitigating the AI impact as well in a different track.
Yes.
Excellent.
So we have projects that focus on AI as well. We have, for example, KEDA, which is doing very well and currently, I think, applying for incubation as well. They're a sandbox project. So we have efforts completely separate. With the cloud native landscape, again, we have hundreds of tools which are fully open source. But in addition to that, we have over thousands of tools created by different vendors. So all of these are kind of coming and growing in varied levels based on the interest in community. If there is not, for example, let's put AI is going to dim in interest within the next year, which I doubt, but if that happens, so the interest with the work within our community too. So it really, really varies in terms of the engagement and momentum from the community as well.
Any more? We have one more question over here.
Yes, the Kepler allows to see the carbon footprint of your general deployment, but can you point out the core, main contributors to the carbon footprint and maybe try to optimize them?
So with Kepler, you'll be able to identify emissions at the application level. Ideally, so this is the thing, there are two ways we actually can address emissions. It can be from the energy you consume, and this is definitely something, for example, you can run on AWS on instances that are powered by renewable energy. That's one way. That's kind of the level of your infrastructure. Kepler is the level above, which is your application as well. And it tries to address or to identify if there's any benefits from you, perhaps reducing those emissions. So this is the aim, it's that level, it's the application level rather than the infrastructure. So here, for example, if you have an application that is very high on CPU, for example, or if you have all of these AI workloads that are very heavy on GPU and consuming a lot of your compute power, here's where you'd like to optimize that. So this is like I would say the key element, identify and understand why that's happening.
Thank you.
And one more question over here.
Hello, thank you for your talk. To my understanding, emissions are very dependent on exactly when you're running your workflow. So, for example, in Greece, running at night is far more carbon intensive than running in the morning, for example. So you showed us in Kepler that you can produce metrics from using like statistic average values. Is there any work done to actually be able to use the platforms that provide hourly data or average data in Kepler?
So pretty much observing your emissions per day / per hour, is that what you're trying to observe?
And combining it with published data, for example, from the NSOE transparency platform.
Interesting. I don't think it's going to that level in actually intersecting it with a different data provider for your emissions, but definitely something that will be great feedback for the project. So currently with Kepler, you'll be able to identify those emissions per day. So for example, If you have more emissions in the night, perhaps you wouldn't like to run your workloads, or for example, batch workloads during the night. You'd like to run them in the morning. So again, like here, it's more about identification and observability of your emissions. But when it comes to different integrations and maybe combining that data and getting a bit more granular, I think that's not something yet done. But hopefully this is some work that will help the project to perhaps get to the next level, such as incubation. So I definitely encourage you to open an issue and say, do you do this? How can we address this? And I think this is going to be a first good step, just showing interest within that domain. Thank you.
Thank you, and thank you, Katie. This is a little something for you
An
from
olive tree.
Devoxx Greece, from all the organizing team. Will you be around for the next of the day or tomorrow?
I'll be available today. You can definitely find me around, and you can definitely find me on social media as well. I'm available, pretty much.
Awesome, thank you so much.
Thank you.
Καλή όρεξη, as we say in Greece. Please, everybody, I heard this comment yesterday from one of our awesome guests. Let's give prioritize to our guests, our speakers, when it comes to lunch, so they don't have to wait in the long queues. Καλή όρεξη, as we say in Greece, as for you, and we will see you back in about an hour. Enjoy our break.